This is The Creator Revealed, a production of 3ABN Television.
Welcome to The Creator Revealed. My name's Tim Standish, and I'm a scientist. That means that sometimes I speak a language that doesn't really sound like English. So thankfully, I have here with me Shelley Quinn, who is going to help me
keep you on the straight and narrow.
So we'll stick to English.
Yes, please.
In this fabulous program, in which we are going to talk about what the creation tells us about the Creator.
You know, we're so excited about this, Tim, because first of all, we want to thank the Geoscience Research Institute, who has allowed him this time off to come and produce this series. And we're very excited because creation science is something that is doubted by many. To me, there's so much proof that God is with us, that God created us, and that's what we're going to do here. Now, the first 15 minutes of this program, you're going to get introduced to a scientific fact. The second 15 minutes of the program, we're going to tie that in as to how it affects you in a personal way and how you can put it into a practical application.
I'm looking forward to that part.
Yes.
But of course, as a scientist, what I want to do is dive in to what we are going to talk about. And I want to just prefix our discussion of the science with something that the Apostle Paul wrote almost 2,000 years ago. It may seem like an unlikely thing to choose, but remember that Paul was writing to all kinds of different people back there in the Roman Empire. In this letter to the Romans, he wrote these words. He said, "For since the creation of the world, his invisible attributes," this is God's invisible attributes, "are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." What he is saying here is that we, just as the Romans could, can look at what God made and we can learn certain things about the Creator. In other words, the creation reveals the Creator.
So what is the thing we're going to learn today?
Well, we're going to learn about machines, but not the large machines that you're used to thinking about, things like cars and tractors and cranes and those sorts of machines. These machines operate on exactly the same physical principles, but they are microscopic. In fact, they're smaller than you can see with a normal microscope. They are molecular machines. They're made up of molecules. But first, we need to understand why living things need these little tiny machines inside them. So let's sort of step back and think about how life works. And we all know that the sun shines, and that sunshine, that light that comes down, is a form of energy. And that light energy is what plants use so that they can grow, right?
Is that photosynthesis?
Photosynthesis, right. And so in this amazing process of photosynthesis, there are all these machines, little tiny machines, that are taking energy in the form of light and converting it into another form, into chemical energy. That's what machines do. They convert energy from one form into another form, and by doing that, they do work.
All right, but if that same light source is shining on an inanimate or an object that is not alive, like asphalt, It's not producing anything.
Yeah, exactly. Most people who drive have probably noticed that the roads do not grow and repair themselves when the sun is out. That's not what happens, because roads are not living things, and living things are distinctly different, in part because they have these little machines in there that are doing this work, that are converting energy from one form into another.
All right.
All right. So that's what we're talking about here. Now, the parts of machines, the molecular machines, so these little tiny machines, the parts are made out of primarily protein. Most people know what that is. So there's a question, where did that protein come from? Charles Darwin had a theory about that. Now remember Charles Darwin, he's a materialist. Yes. So he's trying to figure out, how can we do this without God? And he wrote this to a friend. He said, if, and oh, what a big if, we could conceive in some warm little pond with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc. present, that a protein compound was chemically formed, see, not by God, but by chemical formation, ready to undergo still more complex changes. So he's saying, hey, maybe we could get proteins in a warm little pond that was full of chemicals. But there's a problem with that. And you have to understand how these protein parts are made. So let's take a quick look at that. Okay. So proteins, they're made out of things called amino acids. And those amino acids can be joined together by removing a water molecule. And you can just join them together one after the other. Usually proteins will be hundreds of these amino acids long. And each one of them is joined together by removing a water molecule. So you don't have to. Yeah, you don't have to be an expert chemist. Yes. What's going to happen?
It's not going to proteins are not going to be developed according to Darwin's theory in a warm little pond, because if you were trying the process in a pond, it's going to add H2O elements, not the reverse.
Water is what's in ponds, right?
Right.
So water is going to go into things, not come out. So how is it then that in living cells, they can make proteins? Because remember, our bodies, those cells that our body is made up of, they're more than 50% water. So how is it that this happens? And the secret is, again, in machines. There are machines that take the amino acids and bring them together and remove that water molecule. They use energy to do that work. Okay? There's a lot of power involved in all of this. So think about the irony of that. You've got to have the machines to make the proteins from which the machines are made. It's like a chicken and egg situation. You've got to have the whole system functioning before you can have any of it functioning at all.
Boy, that's a statement that, to me, really supports an intelligent creator, our God.
Oh my, yes. So let's continue on. I'm going to show you a protein machine, one of these machines. And this particular machine is like a wind turbine. Exactly the same principles are involved. So on a wind turbine, that wind energy starts the turbine turning, and that energy is transferred then to a generator, right? So the wind energy is then converted into electrical energy. That's how it works. The same principles are involved in this fabulous little tiny microscopic, submicroscopic machine called ATP synthase. It generates energy. It provides power to your cells. So that part there that you can see at the top, the blue part, is like the turbine. It twists things around, and down at the bottom, the red part is the generator part. It makes this substance called ATP. And you can see that they're joined by a protein that transfers that twisting energy, a drive shaft protein.
So without the protein, nothing would be happening, though.
Exactly. You'd have a a turbine spinning around doing nothing, and a generator sitting there doing nothing without that drive shaft protein joining the two things together.
Is it fair to say a protein then is a building block at the cellular level?
Yes. Oh, okay. Yes. Yeah. They are the very parts that these machines are made out of. And if you're missing some of the parts, the machine isn't going to function at all. Huh. All of these machines require a set of parts. So one protein isn't going to do much for you. You've got to have a whole lot. Here's another machine that's also involved in what we call the energy metabolism of the cell. Let's not worry.
This is a little bitty microscopic thing that we just looked at.
Yeah, this is just another way of showing what these machines look like, and the different colors of different proteins there.
How amazing.
Really a complicated thing. The reason I wanted you to see that particular one is because it's part of something we call the glycolytic pathway. That means sugar splitting pathway. This is 10 different machines that are equally complex, sometimes more complex than that one that I just showed you. And each one of them has to do their job, because if they don't, you've got a big problem on your hand. You're turning sugar, in this particular case, into another chemical called pyruvate, and you're getting energy out of the sugar. The problem is you've got to put energy in at the beginning. This is like lighting a match to start a fire. You're putting a little bit of energy in, and it's not until later on in this process that you start getting out chemicals that are actually useful for energy. So that protein, that protein is at step number 6 in this series of steps in this assembly line, if you want to call it. It's a de-assembly line.
So splitting the sugar is what gives us the energy.
Yes.
And if any one of these steps is missing, it's not going to happen.
And every single living thing has this whole pathway in there. It's not just one or two machines, it's a whole set of machines working together.
In every little cell.
In every single human cell, in every single rat cell, in every single fish cell, in every single bacterial cell, every single plant cell.
That's amazing.
Yeah.
Okay.
It's jaw-dropping when you think about it.
Okay.
So, what can we learn from this? What does this tell us about the Creator? Well, remember what Paul said about power.
Yes.
God's eternal power. I would suggest that there are two things. First of all, God's power is revealed in the numerous machines He created so that life can exist. In addition, His power to create and sustain is revealed in the intricate mechanisms hidden within living things. So these are invisible to us, and yet when we dig down, when we zoom in and look, there they are, and they tell us something profound about the Creator's power.
That is astonishing. I think I want to just think about for a moment how God, the Bible says we are fearfully and wonderfully made, and how amazing it is that all of this is going on in every cell of our body. Think about how amazing it is that we're as healthy as we are when there's so many things that could go wrong.
It's a miracle, isn't it? And we're going to talk a little bit more about this miracle, but we're going to do it 60 seconds from now.
All right.
So please do not go away.
Welcome to the Minute That Makes a Difference. I'm Margot Marshall. What difference would it make if you ate beans daily? There are 10 compelling reasons. Here's one. Beans are a rich source of antioxidants, and the little red azuki bean has more antioxidants per serving than any other fruit or vegetable, even higher than blueberries. That's just one reason the United Nations declared 2016 the International Year of Pulses, which is another name for beans or legumes. What's so good about antioxidants? They protect against heart disease, cancer, strengthen the immune system, and slow down the ageing process. So enjoy some of the hundreds of varieties of beans every day in soups, salads, casseroles, or on toast for breakfast. Beans make a difference.
Welcome back to The Creator Revealed. Today we're talking about molecular machines, the little machines in molecules, and who better than a nanochemist to have on the second half of the program.
Exactly. Dr. Ryan Hayes teaches chemistry at Andrews University. He is a nanochemist. That means a chemist who makes really tiny, tiny, tiny little things. Now, we've been talking about nano machines, really, when we're talking about those machines, those molecular machines inside the cells. So let's meet Dr. Hayes. Let's ask him a little bit about what exactly a nanochemist does, and then we can get into some nano machine stuff. Yes.
Hi, Dr. Hayes.
Excellent.
Welcome.
Thank you. Thanks for having me on this program. This is exciting. Now, we got to be careful about the term nanochemist, because some people may think that just means I'm a really, really small chemist. And that's not the case.
I've met you. You're completely life-sized, yes.
Yeah, that's right. But I do study, and actually, we actually have a company that I'm a part of where we make nanomaterials. And so to a chemist, actually, nanomaterials are quite large. But to our eye and to everyone else, nanomaterials are very, very small. So small that you can't see them. But they are a collection of atoms and molecules to form large chemical structures to us. But they're usually precisely engineered and controlled to give you the right size and functionality to do really interesting things. And a nanoscientist, nanochemist, there's some out there trying to build little nano cars and nano-sized batteries. And I like to build nano-sized versions of this little suction ball cup. I could say more about that. As a little shout out to my students who know I like to talk about nanomaterials that look like this. And but inside our body, there's just an amazing amount of nano-sized structures doing amazing things there.
So maybe you could tell us. Yeah, maybe you could tell us a little bit about what precisely it takes to make these really small structures. First of all, are they something that you can see under a microscope, or how would you are they smaller than that even?
Well, they're definitely smaller than what you can see with a microscope. People have been able to Scientists have been able to visualize them with things like an electron microscope or an atomic force microscope. And so we have ways of actually getting visualization of them, getting their structures, but to build them, boy, this is a real tough job. And it takes a lot of knowledge of chemistry and the rules of how chemicals react with each other to overcome thermodynamics. These things want to just spread out, but we want to bring all the molecules together. So there's some organization that needs to be thought of in advance to bring these things together. So I do this on a daily basis.
So what you're saying then is there has to be a plan when you start. You can't just sort of walk into your lab and say, let's see what happens when I mix together these chemicals today.
That's exactly right. Now, my students would hope it would be like that. Let's just mix some things together and hope we get some great nanostructures. But no, we have to go in with a plan and a recipe. And even with that, even with our best recipes, we still struggle to make pure products with the desired purpose that we have in mind. So yeah, you definitely need a plan, a good recipe, and a good laboratory space. That's usually needs to be clean. You need to be able to run your reactions without interference, and all at the right time and temperatures. There's a lot of factors that we think about to get to the right structures that we're trying to build. And we built some really simple nanostructures here, especially compared to what we see in living creatures.
Well, let me ask you about that. I mean, you're a smart guy, and you have all of this equipment. If you set out to make one of these little nanostructures, these relatively simple little nanostructures, about how long would it take you to make one? Is it something that you can have a good idea in the morning and have by the afternoon, or is it something that takes considerably longer than that?
That's a great question, and it depends on how elaborate you want your structure. Now, the ones that we make, they can take weeks and months to make the structures that we're looking for, and these are relatively simple ones that have a lot of repetitive structures to them. In fact, that's kind of a problem, is how long it can take, and that drives up the cost, and these things can be kind of expensive. And so, it can take weeks and months. And that's not just letting them sit in a pot and stir like a pot of spaghetti. We actually have to go in. We'll do that part for a little bit. And then we have to pull out the materials, clean them up, and maybe do some purification, and then get them ready for another step. We spend a lot of time doing that. There's some shortcuts you can take, but then you lose out on the structure. You won't get the beautiful structures if you try to take some shortcuts.
But
it's quite a challenge, and it takes quite time.
And what you're saying, Doctor, is that this takes intelligent design and a plan that has to be carried forward.
Oh, absolutely. And even with simple, if there's such a thing as simple nanostructures, you definitely need a plan. You need an extreme amount of knowledge about how these molecules, these chemicals, the atoms, the electrons, how all of these things work. And without a plan, you're going to get a mess. And as one of my advisors said, you put garbage in, you get garbage out. You need really clean materials, and you need a good plan. You need awesome intelligence to think about all of the side reactions that can happen and all the ways to go wrong so that you can prevent those from happening. As much as we would like chemistry to just happen, being in the lab has proven to me that this is quite a challenge to make even simple nanostructures.
So what do you think about Darwin's theory of the warm pool and the chemicals coming together for this little amoeba-like structure?
Yeah, that's a great question, and it's important to know the history right there, and I won't go all into that, but much of Darwin's thoughts were formulated well before chemistry was even established in the way that it is in the modern scientific way that we know how chemicals react. And he thought there was just, a couple, 4 or 5 chemicals that came together in a little bubble to make life. And we know now it's thousands of chemicals coming together in a complex, not bubble, but a surrounding and an amazing amount of nanostructures that have come together, not just one nanostructure, but many of them that have come together to form a working, living system. So a warm little pond, I think we would love it if it was that easy. But the more we know about life and the nanostructures and the nanomaterials that life is made out of, we understand the complexity that's there. And I think there's a desire, that scientists think, well, maybe we're missing something. There's some theory that's going to come along and change all of this. Well, the more we look, the more complicated it gets. So this problem's not getting any easier.
So it's getting worse and not better. Let me ask you this. If you think about these nanomachines, these complex nanomachines that we find inside living things, you're making relatively simple nanochemicals. Would there be any realistic expectation that we would even have the technology to make something like these kinds of complex machines that we find inside cells? Or what would that really take?
Well, doing it from scratch, I'd say that we are decades and decades away from that, perhaps centuries from figuring that out. Maybe not, but it's a long time. You know, what a lot of scientists do now is we just copy. We just copy what we see in the cell. We take things out and we try to change them a little bit to give them some new functionality. But all we're doing is modifying the master plan that's already been enacted there. So people are finding it easier just to mimic what we see in life rather than trying to just start over.
Basically, we're plagiarizing.
Absolutely. It's so much easier to just use what's there and tweak it for some of our own designs that's there.
So it's fair. I'm sorry, we're just running out of time, but it's fair to say that you absolutely believe that God is our creator.
Absolutely. I can see it, the handiwork, when I see the chemicals coming together. When we look at a house, we don't go, well, those pieces of wood and nails just blew together with the right temperature and wind speeds. So there's no question when we look at a house that someone built it. But when we look at molecules, we say, oh, I have no idea how that happened, so chance could do that. But when we understand the chemistry and the mechanisms there, we start to see the hand of a designer. I absolutely believe that God is the designer and the head chemist that put all of this together so that we can have life and have life abundantly.
Amen.
Well, thank you so much for joining us, Dr. Hayes. It's been a real pleasure. And there have been some pretty deep insights there.
Yes, amen. And it's just exciting to think about, though.
Yeah. I cannot imagine at this particular point how you could put a living thing together from scratch, even if you did have all of those parts that are necessary. It's truly a triumph of a kind of technology that we certainly haven't mastered, and it certainly points towards an incredible brilliance that's
And when
there.
you think about it, I've heard this example before. If you have a junkyard and you throw a bomb out there, you don't end up with a shuttle. And that's what many scientists who support Darwin's theory seem to be trying to sell us. Well, we hope that you've been encouraged to understand that God created you and He loves you.
You've been listening to The Creator Revealed, a production of 3ABN Television.